Hi, today I'm just going to give you a brief introduction to the Genie and some of the functionality that we've got built into this instrument. So Genie is a multifunction calibrator, so we can source and measure milliamps, millivolts, ohms, frequency, and it also integrates with our pressure system as well to do pressure calibrations. Today I'm going to show you quickly how to set up the instrument for an RTD simulation into a transmitter. So we can set the 4 to 20 milliamps on that transmitter. Okay, so the Genie has a capacitive touchscreen, so very much like your smartphone, which we're all used to, and it's very intuitive. So we have graphics on the front here. So as you can see, at the moment we've got highlighted the Calibrator, which is what I'm going to go into shortly. We also have the HART communication functionality, the Fieldbus functionality. We get into our settings. We can look at the status, the software build, because we can upgrade this and do improvements to the software and upgrade it from time to time. We can scroll down, we get to our advanced settings where we get into our calibration features. So this is our front screen, and we can always get back to this by pressing the home button. So what I'm going to do now is go into calibrator mode and show you how easy it would be to do an RTD transmitter simulation and setup. So this is calibrator mode. Now we can set a number of channels on here. At the moment there's 2 channels been set up. We got channel 1 and channel 2, and on the screen we're displaying those 2 channels now. Okay, so on channel 1, as you can see, we've got some graphics on there indicating what we can do. We can measure or source or measure a full 4-wire RTD, which up to a 4-wire RTD, and it will test all the compensation lines on there. We have our thermocouple connection here. And over on this side we have a milliamp and a 24 volt power supply. So we're working with the transmitter, so what I want to do is power that transmitter from this device. So I'm going to provide 24 volts to do that, and as this transmitter's input is an RTD, I want to simulate an RTD on channel 1. Okay, so I can actually go into this manually and do what we call a custom task and set that up for each one individually, but we also have our electrical tasks set up in here to make that a lot easier for us. And if we scroll down, and what I'm looking for here is channel 1, I want an RTD, and channel 2, I want milliamps and 24 volts. The other good thing on the graphic, it shows me where I need to connect to on these 2 channels. So quite simply now, I will select channel 1 RTD and channel 2 24 volts and milliamps. So we just select that. We can actually select these as well and put them into our favorites menu. So when you go into your favorites, if they're tasks that you use, quite commonly, then you don't have to go and scroll through all the different tasks. You've just got your favorites already set up. So at the moment it's shown at the top here we have degrees C. So this is going to be where I'll simulate the RTD resistance into the transmitter. At the bottom here we have our milliamp output from the transmitter, which I will connect shortly. So here I have a rather old RTD transmitter. It's a 3-wire. When we're actually sourcing or simulating, we don't need to connect all 3 wires independently. So what I've done is I've joined the compensation wires together there. We make a simple connection on this side. So it doesn't matter which way around I do this, it's a resistance. So that's channel 1. So if we look on here, channel 1 is degrees C. Now it's a transmitter, so as you remember before, we've got 24 volt supply on channel 2. Connect that in, and straight away 0 degrees C is 4 milliamps. So this is PT100, 0 to 100 degrees C. So now what we want to do to calibrate this transmitter and set it up will be to simulate the temperatures. Now there's a number of ways that we can do that. We can simply go in and we can edit the value and type in what we need to do. And so if I want to go to 50 degrees C, I enter 50, hit the tick button. We now have 50 degrees C. I press on the bottom channel, you'll see there's nearly 12 milliamps, which is half of its range. So if I go back to this though, now I want to do this a little bit faster and a little bit easier for myself. So let's say I just want to do a quick check. Once we press on that channel, it opens up that screen. You can still see your 12 milliamps at the bottom. But if I go into setup now, it gives me some options here. For example, I can change the units to degrees F. But But what I'm interested here is I can obviously change the RTD type. We have 12, actually 14 different RTD types in there. This one is PT100, which was already set up. So I can go into the automation side of this, and on the automation at the moment I've got nudge value. So I can nudge this up and also adjust the step size of that nudge. Currently it's set at 1 degree C. Right, so every time I press the arrow it'll go up or down by 1 degree C, and obviously I can change that to any value I wish I want to. But to make it easier, let's do a process here, and we can put a defined step in there, or we can do a simple span check, or we can do a percent step. So if we go into percentage step, the process is percentage step. At the moment we've got the step size in 10%. The low currently is set to minus 200 degrees C, which would be 4 milliamps, and 850, which is actually the full scale or the full range of a PT100. But in our case it's 0 to 100 degrees C. So I need to go in and change that. So 0 is our low, and our high is 100. Okay, so we'll step in 10% steps. Now if we come back, we accept this, and as we go up now, it's 0 to 100, so every 10% is 10 degrees C. I can quickly step through, check the milliamps output at the bottom. So we're going up to 30, 40, 50, so nearly our 12 milliamps, and so on, right up to 100%, 20 milliamps. In fact, it's set very close and it's well within tolerance at the moment. Obviously, if I needed to adjust that, I can. I can also configure channel 2 to display the percentage error. It takes a little bit more time, but that can be done as well, so you can actually see how far out of spec the setting is on the RTD transmitter. Stop. One of the nice features we can do on the configuration, obviously at the moment we are sourcing and simulating temperature and reading milliamps out. What we can do is turn the scaling on in the system here. So instead of looking at 4 and 20 milliamps and working out what that is in degrees C and the error, we could turn on the scaling quite simply, and in the scaling, I'll just scroll it up a little bit. So on the scaling we can enter the measured value here is 4 milliamps equals 0 degrees C, and the measured value at 20 milliamps equals 100 degrees C. I can change that label to F or whatever, or percentage, anything I need. Hit the tick button and come back, and now the scaling, as you see, we're not now reading milliamps on the bottom here. We've got 100 degrees C is what we're simulating. I can open that up, you can see 100 degrees C, and at the bottom we're reading, instead of milliamps, almost 99. And if we go back to the top, and if you remember now, we can nudge this down, come back down to 0 degrees C, and at the bottom, instead of 4 milliamps, we now have approximately 0. So we can see what the error is in actual temperature rather than just milliamps. Hopefully that gives you a brief introduction to just one of the many things and many functions that this instrument, the Genie, can do, and how easy it is to use, and the intuitive capacitive touchscreen really is, you know, a market leader. So thank you for watching, and look out for more videos and functionality of the Genie product from GE Druck.